Hi everyone, my name is Neha and this is the 12th lecture on Introduction to Automation. In this lecture, we are going to learn about liquid level sensors and vision sensors. Liquid level sensors, they measure the height of a liquid in a container, and these type of sensors, they have been around for decades in markets such as food and beverages, industrial, medical and domestic, printing, agriculture, automotive, etc. And these type of sensors, they are classified into two types. First is discrete level detectors and second one is continuous level detectors. So in the discrete level detectors, it can only detect whether the liquid is at a certain level. Whereas in continuous level detectors, it provides an analog signal that is proportional to the liquid level. So as the liquid level increases or decreases, the analog output can be obtained corresponding to the change in the liquid level. Now let's see discrete level detectors in detail. Discrete level detectors, as you know, it can only detect whether the liquid is at a certain level or not. And in this type, the application includes, for example, to determine when to stop fill cycle of washing machine. And a few examples of this type of detector has been given over here. Let's see them one by one. First, we have float and switch. In this, you can see in the tank we have some liquid, and then we have this float which is connected vertically to this cam and the limit switch. So this cam basically helps in moving the vertical rod up and down, and then we have limit switch attached over here. So what will happen at a certain liquid level, this cam which is attached to the rod activates the limit switch, and activation level, it can be adjusted by relocating either this cam or by this limit switch. Float and switch, this is one of the common type of discrete level detectors you might have seen in the water tanks at home. And next we have photo sensors. You can see here there's a tank with a liquid inside it, and then you have a photo cell and a light source. So when the liquid level is lower, then the light source will directly incident on the photo cell, and as the liquid level increases and it crosses this light source, then the sensor detects that the water level has reached to a certain level and indicating the presence of the liquid. Next we have a resistance probe. As you know that many liquids like tap water, weak acids, beer or coffee, they are slightly conductive, so they can be detected by electric probes. So if you suspend or if you put the electric probe inside the tank like this, then what will happen, as the liquid level increases and it reaches the probe, then the resistance in the circuit it will decreases, and that decrease in resistance basically tells at what level the liquid has reached. And if you see the application of this resistance probe, this can be used in automotive low coolant sensor. Now next we have continuous level detectors, and in this you know that continuous level detectors, they provide a signal which is proportional to the liquid level, and you can continuously measure the change in level of the liquid with this type of sensor. One example of this type of sensor has been given over here, which is float and pot, and this type of sensor is very similar to what we have seen in the discrete level detectors. The only difference is that here, along with the float, we have this position sensor which is shown over here, and a weight is put over here. So as the float goes up based upon the liquid, as it increases, this float will go up and this weight will go down. And as this whole changes, then what will happen, the position sensor here, so let's say we are using here potentiometer, then this potentiometer, this will basically it indicates the level of the change. So this is one type, and then we have another type which is sensing pressure head. And you can see here the pressure sensor has been placed over here at the bottom of the tank, and as the liquid level increases, the pressure inside this pressure sensor head, it will change. So the pressure at this head of the pressure sensor, it will be directly proportional to the level of the liquid in this tank. And this can be given by this equation. You can see here pressure is equals to dH, where D is the weight density, liquid weight per unit volume, and H is the height of the liquid in the tank, and this pressure is the gauge pressure at the bottom. Now let's see further another types of continuous level detectors. Uh, Here you see the weighing tank, and in this tank you have this liquid, and at the bottom you have the load sensors. So here, monitoring the weight of the liquid with this load sensors, or you can say load cells, we can determine the liquid level. So what will happen, the liquid, the load sensor, it will further connect it to some meter, and as the liquid level increases, the value at the meter, it will change correspondingly. And then we have this electrodes measure R and R or C, where R is the resistance or capacitance. So you see here two vertical electrodes, they are mounted inside this tank, and the output of this device, it must be your either in resistance or in capacitance, and that value will be very small, and you can use the amplifier to get the higher magnitude of that value. So this is another way. And then third one, you have the ultrasonic ranging, and you can see here a direct level sensing system has been shown, and it uses ultrasonic range detector, which is mounted on the top of the tank. And in this type, the rays, it will be basically incident on the liquid level. So as the liquid level changes, it will detect that change, and it will send that value to the output, and you can attach any meter or some position sensor, which will let you know that what level, how much the level has changed. So this complete unit, it includes the transducer and electronics, which can be purchased also in the market as a one single module. And this type of system is a little expensive also when compared to the other continuous level detectors. Now next we have vision sensors. A vision sensor is a TV camera connected to a computer. Machine vision is being used to perform inspections and to guide machine operations. So these vision sensors, they use images captured by a camera to determine the presence, orientation, and accuracy of the parts. It is used to provide guidance to a pick and place robot for doing such things like loading, unloading, etc. And they also require computer power to process thousands of pixels of information and continuously, in order to arrive at a particular decision that what has been seen. In the past, this was done by dedicated computer hardware, but now this has changed by development in the PC technology, and that development is by the use of microprocessor and the PCI card. PCI cards are the peripheral component interconnect, and they are used to communicate with the microprocessor at a much higher data rate than the older ISA cards which were used. Now next is the vision system component. It consists of electronic camera connected to special video processing PCI card, which is called a frame Gerber, which has been put over here inside the PC. And you can see here a camera is mounted downward upon the area of the interest. This is our workstation, so it is mounted on the top in downward position. So the visual information from this camera, it will pass to the frame Gerber, and this frame Gerber, it will convert the visual information into a digital format, and then the entire frame is passed on the PC PC approximately up to 30 times a second, and then the computer it will analyze the data and then sends the signal back to the workstation area, either to reject a part that has failed the inspection, or to direct a pick and place robot to move to the next level in the operation. Now next we have an example on vision system. So here on the screen you see a conveyor belt, and on the conveyor belt we have some parts which are moving from one side to another, and on the top we have vision sensor, and this vision sensor is inspecting each object which is passing through the conveyor belt, and if the inspection pass, then that signal is sent through this computer, and if the inspection fails, then that response is also sent through this computer. Now this result is can be collected at a remote location through the computer or through the phone by using the Bluetooth device or any physical wire connection. So this system is an example of a vision sensor and how it can be used in the industry. Now next we have machine vision using edge detection. So there are a number of different approaches to processing the visual data, and it depends upon what particular application you're using. The most common we know is the edge detection method, and in the edge detection the computer is used which defines the edge of the object. So the computer, as you can see here in the picture, this is the actual TV picture and this is the edge detected image. So here the computer, it will scan the entire frame looking for the edges, and it detects on the basis of the grayscale intensity, and then it gets the edge detected image. Now there are three parameters on which the edge detection method is based. First is contrast, second is steepness, and third is the width. So we can understand this from this graph, which is between the distance and the intensity. So let's first see the contrast. So contrast, you see here, this is the contrast, which means there is a numeric difference in the intensity between two adjacent areas of the frame. And then second, we have the steepness. So this steepness tells how quickly the intensity is changing between the areas. And then we have the width. This width tells the minimum size of the uniform intensity area on either side of the edges. So here, based on the application, the outline of the part can be created on the computer, and then the dimension can be checked on the visual image to determine whether the component or the part is accepted in the industry or not. Now let's do some problems. So this problem says a pressure sensor is used to measure the water level in a tank. What pressure would you expect for 2 meters of water? So here we will be using the formula of the pressure, which says P is equals to dH, and here D is already we know that, and the value of that is 9800 Newton per meter cube, and H is given, which is 2 meter. So we will just put it into this formula, and then we will get 19600 Pascal of pressure. Now next problem is a pressure sensor is used to measure the level of the liquid in a tank. The weight density of the liquid is 6000 Newton per meter cube. If the gauge pressure from the sensor is 12,000 Pascal, what is the height of the liquid? So again, in this problem also we are going to use the same formula, which says P is equals to dH. So we will use that formula, but here we have to calculate the height. So D is already known. You know that here it is given, weight density of the liquid is 6000 Newton per meter cube, and the pressure is 12,000 Pascal. So putting these into this equation, we will get the height. So if you calculate, then you will get 2 meter, which is going to be the height. So this is the end of the lecture. Thank you so much for watching.